clue structures for these ions. Show all valence electrons and all formal charges. And we have to do this for amide ion, bicarbonate ion, and carbonate ion. So what we're going to do here is we're going to go over my guide on how to draw loose dot structures, and specifically we will deal with ions, which are molecules that have a charge. So this one has a negative charge, and negative 2 charge. So let's go ahead and get started. The first one is an amide ion, which is NH2 minus. And what we have to do first is we have to calculate the total number of valence electrons in a molecule. And to do that, we have to realize that the number of valence electrons for an atom will be equal to the group number on the periodic table. So for example, if an element is in group 1, it will have 1 valence electron. If it's in group 2, 2 valence electrons, and so forth. Also, it's important to know that if there is a charge, then we have to include that in our total number of valence electrons calculation. So if there is a positive charge, we have to subtract from the total number of valence electrons. For example, if there is +1, we subtract 1. If there is +2, we subtract 2. Electrons were lost. If there is a negative charge, then we have to add to the total number of valence electrons. For this ion, we have nitrogen, and nitrogen is in group number 5, so it has 5 valence electrons, plus we have a hydrogen, which is in group number 1, so it has 1 valence electron, and there are 2 hydrogens, so we have to multiply by 2. And also we have to take care of this charge. This is -1, and we said that if there is a negative charge, we have to add. How much do we add? -1, so there is 1 extra electron, so we add 1, and we will get 8 valence electrons total. Next, we draw out our molecule and put lines between atoms. So let's go ahead. Hydrogens always go on the outside. So if we ever see hydrogens, we always put them on the outside. And next, we have to subtract electrons used in bonds, 2 electrons per bond, from the total number of valence electrons. So how many bonds do we have here? 1, 2. How many electrons were used? There are 2 electrons in each bond, so 2 times 2 is 4. We have to subtract 4, and we have 4 left. We have to use the remaining electrons to make outer atoms happy, but we have to keep in mind that hydrogen only wants 2 electrons. So our outer atoms here are hydrogens. Hydrogen only wants 2 electrons, and it already has 2 electrons. Each one of these hydrogen has 1, 2. So if we do not give it any more electrons, where do our 4 electrons go? The remaining electrons have to go on the central atom. So 4 electrons go on the nitrogen. Next, we have to check if everyone is happy. My hydrogens have 2 electrons each, they're happy. And my nitrogen, does it have an octet? Happy means an octet. Octet means 8. Does my nitrogen have 8 electrons? So let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8. My nitrogen is happy as well. We have written out the loose dot structure for amide ion. And next, what we're going to do is we will go ahead and calculate the formal charge, which is the number of valence electrons minus number of bonds plus number of lone electrons. For hydrogens, the formal charge will be 0, so we don't have to really look at them. So we will be looking at this nitrogen. For this nitrogen, how many valence electrons does nitrogen have? Again, nitrogen is in group 5 on the periodic table, so it has 5 valence electrons, minus how many bonds does it have? It has 1, 2 bonds, plus how many lone electrons does it have? 1, 2, 3, 4. 4 lone electrons. 5 minus 6 is minus 1, so we put minus 1 on the nitrogen. Does it make sense that the nitrogen has minus 1? Well, the molecule has a charge of -1, And so this molecule also has a charge of -1. So that makes sense because it matches its formula. This is our A. Let's go ahead and do bicarbonate ion, which will be BHCO3 minus. Hydrogen is in group 1, so it has valence electron. Again, we start by counting the total number of valence electrons. Carbon is in group 4, so it has 4 valence electrons. Oxygen is in group 6, so it has 6 valence electrons, and there are 3 of them. And finally, we have to take care of this charge. Again, the charge is -1, which means we have to add 1 electron. So here we have 6 times 3 is 18, plus 2 is 24. So we have 24 valence electrons. Next, let's go ahead and draw out the molecule. If we ever see carbon, it's going to be the central atom, and it's attached to 3 oxygens, and one of the oxygen is attached to hydrogen as well. So let's put a hydrogen here. Next, what we're going to do is we will subtract electrons used in bonds. We have 1, 2, 3, 4 bonds. There are 2 electrons per bond, so 4 times 2 is 8, so we have to subtract 8, and we're going to get 16. Next, let's go ahead and we will use the remaining electrons to make our atoms happy octet. So my hydrogen here is happy, and we have to make these oxygens happy as well. Again, they want 8 electrons, and right now this oxygen has 1, 2, so it needs 6 more. So 1, 2, 3, 4, 5, 6, and same here. 1, 2, 3, 4, 5, 6. So we just use 12 electrons, and we have 4 more, which we will put on this oxygen. 1, 2, 3, 4. And we have no electrons left. Is everyone happy? So let's go ahead and check. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Same here. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Now let's check the carbon. Is the carbon happy? Has 1, 2, 3, 4, 5, 6. It has 6 only, but it wants to have 8. So it is not happy. It does not have an octet. How do we help it? We will use double or triple bonds. And what we have to do is we have to use electrons from the atom that it's connected to, because we have no more electrons left. So what I'm going to do is I'm going to choose either one of these oxygens, this one for example, and I'm going to use the 2 electrons here. I'm going to raise them, and instead I will make a double bond. Now let's check if everyone is happy, including this carbon. The carbon is 1, 2, 3, 4, 5, 6, 7, 8. So the carbon has 8 electrons, therefore it is happy. The oxygen here has 1, 2, 3, 4, 5, 6, 7, 8. The oxygen is happy as well. Next, let's go ahead and check for the formal charge on each atom. So this oxygen here, again, formal charge is number of valence electrons. Oxygen is group 6, so it has 6 valence electrons, minus, how many bonds does it have? 1 plus 1, 2, 3, 4, 5, 6. 6 minus 7 is -1, so this oxygen has a -1 charge. What about this oxygen? This oxygen 6 minus 2 bonds plus 4 electrons. 6 minus 6 is 0, so it has no charge. If you check this oxygen, you will see the same. It will be 6 minus 1, 2, 3, 4, 5, 6. 6 minus 6, 0. And carbon would be, let's just go ahead and do it 4, because it's in group 4. It has 4 valence electrons, minus 1, 2, 3, 4. 4 bonds plus 0 lone electrons, so it's 0 as well. So this is the only oxygen that has a negative charge in this molecule. Does it make sense that the overall charge of the molecule is -1? Yes, because the formula has -1 charge, and the overall molecule has all of the charges add up to -1 as well. Now, let's go ahead and do carbonate ion. I'm going to do it right here. And this is CO3 2 minus. The charge is a little different here. So again, we start by counting the total number of valence electrons. Carbon is in group 4, so it has 4 valence electrons. Oxygen is in group 6, so it has 6 valence electrons, and there are 3 oxygens. Now we have to take care of this. This is 2 minus, which means we have to add how many? 2 electrons. So now let's go ahead and do it. 6 times 3 is 18, plus 2 is 20, and we have 24 electrons total. Next, we're going to write our molecule, carbon with 3 oxygens. So let's go ahead and do that. And what we're going to do now is we are going to subtract electrons used in bonds. We have 3 bonds, 2 electrons each. 3 times 2 is 6, so we have to subtract 6. 24 minus 6 is 18. We have 18 electrons left. Now let's distribute them on oxygens. We will give 6 electrons to each oxygen to make them happy to have an octet, like so. Minus 18. I have 0 left. Now I'm going to see if there are any electrons left. No, so we can skip that. Check if everyone has an octet, and if not, we have to use double or triple bonds. This carbon here has 1, 2, 3 bonds, so it has 1, 2, 3, 4, 5, 6 electrons only, but it wants to have 8. What do we have to do? We have to erase electrons from one of the oxygen and make a double bond. It doesn't matter which oxygen I use, and actually using different oxygen, those are called resonance forms. So if I use this oxygen, that's one resonance form, this oxygen is another, and this one is another. Same thing for part B. But they're not asking us for resonances here, so we're not going to do it, but I'm just bringing this to attention. So now is everyone happy? 1, 2, 3, 4, 5, 6, 7, 8. This oxygen is happy. So is this one. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen happy. 1, 2, 3, 4, 5, 6, 7, 8. So everyone is happy now. And what we have to do is we have to do the formal charges now. This oxygen, the formal charge will be 6 because it has 6 valence electrons minus 1 bond. And how many lone electrons? 6. 1, 2, 3, 4, 5, 6. So 6 minus 7 is minus 1. It's going to have a minus 1 charge. This oxygen is exactly the same. You can calculate it separately, but it will also have a minus 1 charge. If we check this oxygen, 6 minus 2 bonds plus 1, 2, 3, 4. 4 electrons. 6 minus 6 is 0, no formal charge. Now again, and for carbon also, we will have 4 minus 4, there will be no formal charge. So does it make sense that there are 2 oxygens in this molecule that have minus 1 charge each? And the answer is yes, because the overall charge here is minus 2, and so is the overall charge of my molecule as written in part C. This is Maya Alochi from Transformation Tutoring, and I really hope that you enjoyed this video.